Hello children, hope you are all doing safe. Now we are going to see the next chapter, Geometry from Star Max Part C textbook. Basic geometrical concepts. Point, line segment, ray, line. What's a point? A point in geometry is a location represented by a small dot marked and it is named by capital letter. Here the point P. Line segment, the straight path between two points and it has a fixed length. So here is a line segment AB and it should be denoted as AB bar. Ray. It is a line segment extended endlessly in one direction. So it starts at one point and travels in one direction endlessly, which doesn't have any fixed length. So it starts at the point X and travels towards Y endlessly. So it can be represented as XY, a bar with an arrow mark, one side arrow mark. Line is also a line segment, but it extends endlessly in both directions. So here is a line travels in P and Q both the direction endlessly, and this can be denoted as PQ, a bar with two arrow marks. Next we are going to see intersecting lines and parallel lines. Intersecting lines are two lines when they cross each other in a plane at one single point, and the point where the two lines meet is called intersecting point or point of intersection. Consider these intersecting lines AB and CD. Here these two lines meet at a point I. So here I is the point of intersection. Parallel lines. The lines which never intersect or cross each other at any point are called parallel lines. Here, consider these two lines AB and XY. They never intersect, but they travel in the same direction. So we can call AB is parallel to XY. Now let us do task 1. Classify the following as point, line segment on ray. So first I'm going to do the first sum. Consider this figure. It has two arrow marks in the 2 points, which means if you have arrow marks, it is a line, correct? So it travels in the direction of S and T endlessly. So line ST, this is a line. Next is sixth sum. There is a point which is being named with the capital letter X. So this is nothing but a point X. Seventh one, a starting point N and it travels towards S with an arrow mark. So it is a ray. So it is ray NS with a bar with one arrow mark. Try the remaining sums in the textbook, children. Next we are going to see how to measure the line segments.
Now I am going to show you how to measure a line segment using the ruler. So take your ruler. Okay, we should always start measuring any line segment from 0 centimeter. Now consider the first sum of part C task 4, page number 4 of your textbook. Now I'm going to do the first sum. Listen carefully how to measure the line segment. So first sum is CD in the line segment. Here you can see the point C. So here 0 centimeter exactly should touch the C point. So now I am keeping my ruler exactly the point on C and I am checking where the D point in my ruler. D point exactly touches the 3 centimeter. So the measurement of this line segment CD is 3 centimeter. So let me write 3 centimeter. Understood how to do it? Let us do one more sum. Third sum. Here M, N, they've already named the line segment. So what is the first step? M is here. We have to keep our 0 centimeter exactly on this first point and check where the end point lies. Where the end point lies. It lies exactly at 5 centimeter. Okay. So now the length of this line segment is 5 centimeter. Let us do one more sum, which is the fifth sum. So as usual, the first point is keep 0 centimeter exactly on S and check where this T point lies. T point exactly lies under, can you see, 0, 1, 2, 3, 4, 5, 5.5 and one more line, which means 5.6. 5.6 centimeter. Understood, children, how to measure a line segment? Now let us see how to construct a line segment. I am going to do a sum from task 5, third sum 3.4 centimeter. So here they didn't give any name for the line segment, for example A, B, C, D, X, Y. So once we constructed the line segment, we ourselves can name it. So always we should start with a point in geometry. So first mark a point. Keep your ruler exactly the 0 centimeter on this point. 0 centimeter on this point. Now the measurement we have to draw is 3.4 centimeter. So let us check 3.4 in our ruler. So 0, 1, 2, 3. We know this big line is 3.5. Our measurement is 3.4. So let us count the small one, 2, 3, 4. So it is 3.4. We mark 3.4. Mark a point on it. Now join these 2 points with your ruler. Okay. So length of this line segment is 3.4 centimeter. Since they didn't give you any name, let us name it as PQ. So we have drawn a line segment PQ of 3.4 centimeter. So I'll do one more sum for you. Fourth sum, 6.3 centimeter. So what is the first step? Mark a point. Keep your ruler exactly the 0 centimeter on the point. Our measurement here is given is 6.3. So we have to go from 0 to 6.3. 0, 1, 2, 3, 4, 5, 6. And the smaller one, 1, 2, 3. So 6.3. Now join these 2 points using a ruler. 6.3, and again let us name the line segment like A, B, any capital alphabetic letter. Understood how to construct a line segment?
Now we are moving on to angles. Angles, when two rays originate from the same point, forms an angle. Here AB, BC are the two rays, forms an angle. So the part inside the angle is called interior angle and the outer side of the angle is called exterior angle. The points inside the angle like point X and point Y are called interior points of the angle, and point P and point Q are the exterior points in the angle. Now consider this table. So here AB and BC are called as arms of the angle. The two rays which forms an angle are called arms. So here the arms are AB and BC. And vertex. Vertex of vertex of an angle is nothing but where the two rays meet. So here AB and BC meet at a point B. So here the vertex is B. Now moving on to angle. This ABC angle can be read it as angle ABC, and this can be written it as angle ABC. Can you able to see this? Angle ABC. Now the interior points of the angle are point X and point Y, and the exterior points are point P and point Q. Why? Because the part inside the angle is called interior angle. The part outside the angle is called exterior angle. Now measuring angles. So we follow these things while measuring angles. We measure angles in degrees, and we measure and draw angles with the help of protractor. Here is a protractor. A protractor has a curved side which is marked angles from 0 degree to 180 degree. Now the straight side of the protractor has a midpoint on which the vertex of the angle has to be placed. The line on the straight side runs through the midpoint and over the arm. The angle is then read from the protractor counting 0 degree to where the other arm lies. Now let us see how to measure an angle.
Now I'm going to show you how to measure an angle. We know that we should measure and draw the angles using protractor. Okay, so here is a protractor, and can you see this point? This is the midpoint of the protractor where it should coincide with the vertex of the angle. Exactly the vertex of the angle. Now here one 0 degree and here is one 0 degree. So our arm will decide where we have to start from. If the arm is in the right hand side, we should start from this 0 degree. If the arm is in the left hand side, we should start from this 0 degree. We should start measuring the angle from this 0 degree. So now I am going to do the task 7 in your book, page number 8. Here they given the question as with the help of a protractor, measure the following angles. Okay, so 1, 2 and 3 they've already did. I'll show you how to measure the angle, the fourth sum exactly. Now consider the sum. Can you see where is the vertex? Vertex is nothing but where the two arms meet. Okay, this is a vertex. Now, if this is a vertex, check where is the arm is. Arm is in the left hand side. Now, first keep the protractor exactly on the vertex. The midpoint should coincide with this vertex. Children, listen, you should not keep this as your baseline. The black line, can you able to see in the protractor? That should touch your arm and the midpoint should coincide with the vertex. Exactly like this. Okay. Now, my check where the arm is. Arm is in the right hand side or left hand side? It is in the left hand side. So we should start from the 0 degree of left hand side. Now, check where the other arm lies in the protractor. Here 0, 10, 20, 30, and can you able to see it is exactly going to 50 degrees. 50 degrees. Okay. So the angle is measuring 50 degrees, and they asked us to, they didn't name the angle. Let us name the angle as A, B, C, and you can write it as angle A, B, C is equal to 50 degree. Okay. Now let us try one more sum. Consider this fifth sum. Can you able to see that they have given the angle in the upside down position? It's nothing but you can rotate your textbook and keep your protractor like this. So now here is the vertex. We know that this 90 degree should exactly, the midpoint should exactly touch the vertex. Keep the vertex like this and the arm should be on the baseline. Now the arm is in the right hand side. So here is a 0 degree. Check where the other arm lies. It lies exactly on 60 degree. So the angle here is 60 degree. Let us name this angle as PQR. So angle PQR is equal to 60 degree. Understood how to measure an angle?
Types of angles. Acute angle. An angle whose measure is less than 90 degree is known as an acute angle. So angle PQR is an acute angle. Right angle. An angle whose measure is 90 degree, exactly the 90 degree is known as right angle. So here angle ABC is equal to 90 degrees, so it is a right angle. Obtuse angle, an angle whose measure is greater than 90 degree is known as obtuse angle. Here angle XYZ is greater than 90 degree, so it is an obtuse angle. Types of angles continued. Straight angle. An angle whose measure is exactly 180 degree is known as straight angle. So here PQR is 180 degree. The angle formed in PQR is 180 degree. So it is a straight angle. Reflex angle. Reflex angle. An angle whose measure is greater than 180 degree but less than 360 degree. Here the angle AOB is reflex angle. Zero angle. An angle whose measure is 0 degree. With no degree, there is only the arms present. It is a zero angle. Now complete angle. An angle whose measure is 360 degree. An angle which completes its 360 degree rotation is a complete angle. So here AOB is a complete angle. It starts at A, make a rotation the angle at the vertex O and come back to B. It is 360 degree. So it's a complete angle.
Now let us see how to construct an angle. So I'm going to do a sum from problem set to apply part. Using a protractor, draw the following angles, which is on page number 10 of your textbook. So first I'm going to do the third sum, 95 degree. Before starting constructing an angle, mark a point. So that is going to be a vertex. Okay. Draw a ray. Ray means we have a starting point. In another direction, it will travel endlessly. So I am drawing a ray, which is a arm of an angle. So here is a vertex for me, and I have drawn an arm. Now I have to draw angle for 95 degree. So as I said, when we measure the angle, we said the 90 degree should this midpoint should exactly touch the vertex, and this line should coincide with the arm of the angle. So let me keep the midpoint exactly on the vertex and arm on this 0 degree. Now my arm and 0 degree coincides. Let us start measuring 95 degree using this protractor. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Ours is 95. So 90 and 95 is here. Kindly mark a point exactly at 95. Okay. Now take a ruler, join these 2 points, you will get the angle 95 degree. This should also be a ray. Okay. Now the angle here is 95 degree. Okay. Since they didn't name the angle, let us name the angle, which is X, Y, Z. Now what is the name of this angle? Is X, Y, Z is equal to 95 degree. And what is the type of the angle, children? Since it is greater than 90 degree, the type of the angle here is obtuse angle. Now you understood how to construct an angle and name it.
Moving on to triangles. Triangles. A simple closed figure made by three line segments is called a triangle. Here, the three line segments are AB, BC and CA. And A, B, C are called the vertices of the triangle and ABC. And a triangle has three sides and three angles. See, AB, BC, AC are the three line segments. So it forms three line segment. And we know that angle are nothing but when two arms meet at a point, two rays meet at a point. So here we have got three edges, so there will be three angles formed in the triangle. So the symbol of the triangle is here. Can you able to see the symbol of the triangle? This is the symbol of the triangle. The triangle ABC is denoted as triangle ABC, the symbol of triangle and ABC. The three angles of the triangle ABC are angle A, angle B and angle C. Classification of triangles according to the angles. Obtuse angled triangle. We know what is obtuse angle is. Obtuse angle is nothing but angle which measures greater than 90 degree. So obtuse angle triangle is nothing but if any one of the angle of a triangle is obtuse, which means which measures greater than 90 degree, then it is called an obtuse angle triangle. So consider this triangle ABC is an obtuse angle triangle because angle B measures more than 90 degree. So angle ABC, triangle ABC here at angle B it measures more than 90 degree. So it is an obtuse angle triangle. Next is right angle triangle. As we know that right angle is nothing but exactly the 90 degree, which means if any one of the angle of a triangle is equal to 90 degree, then it is called a right angle triangle. So here triangle PQR, angle at Q is 90 degree. So it is a right angle triangle. Next is acute angle triangle. As we know that acute angle is nothing but angle measures less than 90 degree. So if all the three angles of a triangle are acute, which means if all the three angles of a triangle are less than 90 degree, then it is called an acute angle triangle. Here triangle ABC, can you able to see the angle measured in this triangle ABC? 62 degree, 75 degree, 43 degree, which is nothing but they are less than 90 degree. So all the three are acute angles. So this triangle can be named as acute angle triangle. Moving on to classification of triangles according to the size. Equilateral triangle. If all the three sides of a triangle are equal, then it is called an equilateral triangle, which means length of all the three sides of the triangle are equal, then they are called an equilateral triangle. Here triangle ABC, all the three sides measures 5 centimeter, which is AB, BC, AC, all the three sides measure 5 centimeter. So it is an equilateral triangle. Isosceles triangle. If any two sides of a triangle are equal, then it is called an isosceles triangle. So length of any two sides are equal. Here they denoted as LM and LN are equal. So LMN are isosceles triangle. Moving on to scalene triangle. If all the three sides of a triangle are unequal, which means the length of all the three sides are not same, then they are called as scalene triangle. Here, example, 5 centimeter, 7 centimeter, 9 centimeter. All the three measures different length of the sides. So, it is a scalene triangle. Now, let us move on to circles. A circle is a closed curve, each of whose points is at the same distance from a fixed point inside it. And a circle consists of center, radius, diameter, circumference, and chord. Let us see what are these. Center. All points in a circle are at the same distance from a fixed point inside it. That fixed point is called the center of the circle. Here, point O is the center of the circle. Radius. The distance from the center to any point on the circle is called radius. It is always be equal in length. Chord. Line segments whose both ends lie on the circle are called chord of the circle. Diameter. A chord passing through the center of the circle is called the diameter. A diameter is the longest chord of a circle. Circumference. The distance around the circle or the length of the chord is called circumference of the circle, which can also be called as perimeter of the circle. Relation between radius and diameter. The length of the diameter is twice the length of the radius, which means diameter is equal to 2 times of radius, and the radius is equal to half of the diameter or diameter divided by 2. Now let us see how to construct a circle with the help of radius.
Now we are going to see how to construct a circle for the given radius. I am going to try a sum from problem set 3, apply part, page number 17 of your textbook, fifth sum. Now the given radius here is 2.7 centimeter. Now first step is always in geometry, just mark a point. First thing is mark a point. Now we know the radius is 2.7. There are two ways of drawing the circle, children. One way is first you draw the radius as a line segment for 2.7 centimeter. Then you take the measurement of this line segment using your compass. Then you draw a circle. Or the other method is take a ruler. Now this is your compass. Now keep the needle point exactly on 0 centimeter and the pencil point adjust it to 2.7 centimeter. So here 2.5 and 2.67. Can you able to see now? 2. Yes, now it is 2.7 centimeter in the compass. So from the center, this is the point we marked as the center of a circle. Mark it as O. Keep a needle point exactly on the center of the circle. Just rotate it. Simply rotate it. Don't give pressure on the compass. Okay. Now we are going to join the center point and the edge of the circle to mark the radius. Now can you able to see the length of this line segment? It is 0 centimeter here and here 2.7 centimeter. So the radius is 2.7 centimeter and we have drawn a circle for 2.7 centimeter.
Hope you have understood how to construct a circle, children. With that, we come to the end of this chapter. So in this chapter, we have learned basic geometrical concepts, measuring and constructing line segments, angles, triangles and its types, and circle and construction of circles. Try the remaining sums on your own, children. See you again. Thank you, children, and happy learning.